Welcome to Geometry Pre-AP with Mr. Schroeder. Today we're going to do some more work on circles. Today we're looking at the segment lengths in circles. So we're moving away from arc measures and angle measures, and actually we're going into length now. So moving to different areas. Today we're going to focus in and bringing in the lengths, and also we're going to bring some quadratics into our work today. So let's go over a little bit of vocabulary. All the example problems for today will be found in your packet, but this little bit of vocabulary will not be found there. So when two chords intersect in the interior of a circle, each chord is divided into two segments that are called segments of a chord. So these over here are segments of a chord. So there are four different segments. There are two segments for each chord. Okay, and so when tangents and secants intersect a circle, we have a secant segment, which is from here to here, the secant segment, the whole thing. And so then we have the external part, and then we have a tangent segment over here, which is this piece right here. So we have different kinds of segments. And so we're doing this vocabulary because we're going to use these words, segments of a chord, and secant segments, and external segments in the theorems that we're going to cover today. Okay, so make sure you write those down. Make sure you have these pictures. We'll probably do enough to give you the explanation that you need. All right, so our first one is this theorem says if two chords intersect in a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So here we have two chords, and so we have A times B is equal to C times D. And so this is in your packet, and if it's not in your packet, it's also on your Postulate theorem or on your formula chart, because here I've put them both on the back side of our formula chart. There's all our circle theorems for the angles and arc measures. And over here on the right, here is the first one that we're doing today, and we have the other three there also. Okay, and so with that first one, we take this one right here and we say, since this is two chord lengths and it's intersecting a circle, this part's 5 and this part's x, so we got x times 5 equals 6 times 8. And so then you finish solving that and you got 5x equals 48. And x is equal to 48 over 5. And we just leave it as an improper fraction. We like those. No need to change to a decimal. No need to change to a mixed number. Do anything with mixed number, you got to change it back to an improper fraction before you multiply, divide, things like that. All right, so this next one. The 15 is the whole entire chord. X is this part right here. And we got a 4 and we got a 9. And so if I look at this, the x times, now I need this part right here. I don't know this part. But if the whole chord's 15, that part's going to be 15 minus x equals the 4 times 9. So you can work this out if you'd like. You can pause the video and finish this one and see what you get, or you can just keep rolling along with me here. So 15x equals minus x squared equals 36. And so it's a quadratic. Oh, we love quadratics. Okay, and so we're going to have to, in order to do this quadratic, we're going to have to factor this. So I like to factor it when my x squared is a positive value. So I'm going to move the 15x and negative x onto the right side of the equation. So I have 0 over here, so I have x squared minus 15x plus 36. Remember that when you move the x squared to the other side, the equal sign changes sign, so the 15 changes to a negative. And then if it makes you feel better, I'll use the symmetric property and flip it all back around, so I can get it equal to 0. It just makes you happier. And then we're going to factor this. And so we have an x here and an x here. And what factors are 36? We've got 1 in 36, 2 in 18, 3 in 12, 4 and 9, and 6 and 6. And so I'm looking for the factor that will add to give me 15. So it looks like the 3 and 12. So x minus 3, x minus 12 equals 0. So I get x is equal to 3 and x is equal to 12. We got two values here. That's kind of strange. Actually, it's not in this case, because if x is 3 here, what's left out of 15 to be the other part? Well, that would be 12. And if x here is 12, what's left to be on the other part? 3. And so actually both values work. So there's two different answers that work here. And so there's two solutions for x. All right, so the next theorem here says if two secant segments are drawn to a circle from the exterior point, then the product of the length of one secant segment, so the whole secant segment, which is part A here, times the outside part is equal to the whole secant part times the outside part. So it's always multiplied by the outside part. Try to remember that, because if I give you the inside part, you got to go find the outside part. And so here's some practice problems. So if we look at this first one, we have the whole secant segment, let's say 7 here, times the outside part, which is x, equals the whole secant. And they didn't give me the whole thing. Well, but I can add 15 times, or 15, 9 plus 6 is 15. And then the outside part, which is 9. And so I get 7x equals, how do you know what 15 times 9 is? Well, it's 135. And then I divide by 7, divide by 7. And so x is equal to 135 over 7. Remember, we love improper fractions. They're great. And there's our answer. So pause the video, do that one, see what you get there. And that is a 16 there. All right, so if you got your setups, you'd have 16 times x equals 8 times 6. So 16x equals 48. X is equal to 4. So we got a 4 there, and there's, of course, there'd be 12 left on the inside. And that's that one. All right, so now if a tangent segment and a secant segment are drawn to a circle from an exterior point, then the square of the length of the tangent, so this one right here, this is the tangent, is squared, is equal to the whole secant times the outside part. So it's a lot like the last one, except for you just have the tangent, which you have to square. All right, so if we come here, the whole secant segment, which would be x plus 3, times the outside part, which is 3, equals the tangent squared. And so you can pause video and finish working that. When you're done working that, you should get x is equal to 24. Okay, this one over here you can do. You want to pause the video and work this one, you can. I will not give you all the work for this one. So the whole secant, which would be 11 times the outside part, which is 4, equals the tangent squared. You should get 2 square root 11 as your answer. All right, and so I'm going to put a disclaimer up here. I do this every year, and some people listen, some people don't. This topic is one of the most missed on the test, especially by students who don't always complete all the work or study. Make sure you know these formulas for the test. These problems will slow you down and not allow you to finish the test if you spend too much time trying to figure them out or set them up wrong. So I'm telling you, know those formulas. If you don't, put them on some flashcards. It'll help you because you'll suck time away on these few problems on the test and you'll never make it through the test. So make sure you know your stuff. Formulas make a big difference. If you have to think about the formulas all the time, you're going to struggle. All right, and so work in class will be page 19 that day, and you may start after the notes if you like, so that you can do a little bit of practice early, or you can just wait. That's the end of the lesson. See you the next day.